While I'm making some footnotes, I guess I would also go over magnetic coupling. The big thing about magnetic coupling is just figuring out the direction of that annoying dependent source. You have, say, this one here, for example. This is going to annoy some people. You're going to have something like this. How do you solve it? Actually, let me pull up the exact question where I saw this. Now, I am not going to be solving the circuit. However, I will be showing you how to find the sort of direction of that of this thing here, right? Of the dependent voltage source. So once again, let me draw this out. And again, what confuses people is that, oh, now they're not in parallel. Neither are they linear. They're sort of, at a 90-degree angle. That's scary. Here's a little trick. And this is a very, very cool trick. I don't need to draw all of this because I'm not solving it. So here I have the first inductor. And now the trick you can do... The trick you can do, which is very cool, is that you can just bend the circuit. There's nothing wrong with that. It's the same circuit, right? So this is going to be the dot here. We're going to take the circuit and bend it downwards so that now, all of a sudden, they are parallel. And now you can determine the dots. So the dots, we sort of bending it down here. So the dot is going to be on the bottom end. And then you just bring up the out of that back into the rest of the circuit. So now we've bended the circuit so that we can clearly see that these two dots are opposing. And also some people got a little confused. Opposing, aiding, but it doesn't seem to be in the correct direction. Opposing, let me draw the currents here. So this is going to be I1 minus I2. And this here is going to be I2. Opposing and aiding is just like a technical term regarding the underlying sort of physics of magnetic coupling. They don't actually have to do, say, for example, some people think that this is always opposing. This means opposing. No. All opposing is like a physical, is a physics thing. All that opposing means is that, in our case, is that the direction will be the same as the other current. Just like I described earlier. When it is opposing, the current of the dependent source will be in the same direction as the other current. And we repeat that for this side. There you go. That's it, right? It looks... People get this confusion that it looks like it's aiding, right? Because it's coming in the same direction as the current in the same line. But that's not what aiding means. So don't think like that. And once again, what if these were aiding instead? What if these dots were on the same side? I'll start to use that sort of wording because people are getting confused. What if these dots are on the same side? Now, the voltage source is going to be the opposite of the other current. You see that? That's it. Let's do another example. Let's do a linear inductor. What are the directions here? Let's say the current is traveling downwards. These dots are on the same side. They're both on the bottom side, right? And so if we, this is going to affect that one. This is going to affect this one. And they are going to be opposed. The direction is going to be opposite of the current that's traveling through the inductor, right? So current traveling through the inductor is this way. Therefore, this dependent source is going to be traveling in the opposite direction, upwards. The current over here is traveling downwards. Therefore, same thing over here. What if the dots were flipped? Once again, what if now they were opposing? One dot's on top side, one dot's on the bottom side. What happens now? This dot is affecting the top dot. This dot is affecting, or this inductor really, is affecting that one. And once again, they're going to be traveling in the same direction as the one that's as the current. So this one's traveling down. It's going to affect this voltage source. This voltage source is going to be pointing down. This current is going down. It's going to affect the other voltage source. It's going to be pointing down. And once again, we can apply, just to hammer this point in home, we can apply the same sort of bending the circuit around. Now you'll notice, I'm not too sure why, but we get you get opposite sort of aiding or opposing, but you still get the same answer at the end. If you turn these are the same circuit. I just bended this one to make a 180-degree turn. And once again, if we unbend this, you're going to get the original linear inductors. So this is how you determine the direction of the dependent voltage source when it comes to mutual inductors. There's nothing special, no special cases after this. This is all that it is. So I hope this footnote helped you, and I hope you do well on the exam.